This example gives us a graph and asks us to evaluate 9 different quantities. So let's dive right in. Part A asks us to find g of 2. Okay, so we're finding 2 on the x-axis, plugging it in, going up, and here's our point. So trace that back over to the y-axis. So x goes in, y goes out. So g of 2 must be 3. Off to a good start. For part B, we need some new notation for one-sided limits. So when we use this notation of x approaching a, and then we have this positive superscript here, what we say is the limit as x approaches a from the right. It's approaching a from the positive direction. So that superscript, positive or negative, always refers to the direction you're coming from. So we would say approaches from the right. Similarly, x approaches a, and then we have the negative superscript. That means we're coming in from the negative direction, or from the left. So that's just a little bit of new notation to get used to. Continuing on to part B here, we have the limit as x goes to 2 from the left of g of x. Okay, so now here's 2 in the x, and we're approaching it from the left here. So I'm going to go up to my function and see what's happening here for my function. I'm coming in, let's make this a little bigger. I'm coming in, following my function in towards 2 from the left. I'm not even going to look at the other side from the right. I'm just looking at what's happening here, and it looks like the y value is approaching 2. Right, so here's the y value going over here to 2. It doesn't matter what happens at x equals 2, right? The limit doesn't care what happens at the actual point. It only wants to know what's happening close to it. So as I come into 2 from the left, I'm approaching y equals 2. So this limit is 2. For part C, let's see what happens as x approaches 2 from the right. And I know it's from the right because we have this positive direction here. This positive superscript means we're coming in from the positive direction. That's from the right. Okay, so back down to our graph. Here we're coming into 2 on the x. We're approaching from the right. So up on our graph, we're coming in like so, approaching this point here. And so we can tell that we are approaching the point y equals 3. So as we come in from the right, we're approaching 3. Now part D asks us to find the limit as x approaches 2 of g of x. Well, here's the thing. The limit as x approaches a of a function exists if and only if the right-sided limit equals the left-sided limit, and they both exist. There's some finite number L. Different texts will differ on whether or not this L needs to be finite. For now, let's take it to be a finite number, some finite number L. Back to D. We already know that the limit as x goes to 2 from the left is 2, but as we approach from the right, it's 3. Those are not the same, clearly, so this limit as x goes to 2 does not exist, which we write as D in E often. Does not exist. Okay. Moving on to part E. Back on solid ground again, it's just asking for g of 3. Okay, we can do that. Here's 3, so we go up to g of 3. There it is, so it's 2. The y value associated with x equals 3 is 2. For F, we're back to a one-sided limit. Now x is approaching 3 from the left. That negative here means we're approaching from the negative direction, so from the left. Okay, so let's see here. So we're coming in from the left, approaching 3. So up to our function, it looks like we're down like this. And it's pretty clear that we are approaching the y value of 3. Okay, so the limit is 3, as x goes to 3 from the left, is 3. Part G has x approaching 3 from the right. So we're coming in now from the right. Okay, so on our function, we're down here this time, coming in. So it looks like we are approaching the y value of 2. So that one is 2. Part H asks for g of 4. Okay, no big deal. We know how to find the x value of 4. We know how to trace it up to the function and trace that over to the y-axis. So g of 4 is 3. And then part I asks for the limit as x approaches 4 of g of x. Okay, so now we're back to our theorem here about the existence of limits, and it says it exists if and only if the right-sided limit equals the left-sided limit equals some value L. Well, this is okay for x approaching 4. Look, here's 4 down here, so we come in from the left. Okay, we come in from the right, and it looks like we're approaching 3 for both of them. Trace that over to the y. So the left-sided limit and the right-sided limit are equal in this case, so this one does exist, and it is indeed 3. These examples where they give you a graph and then ask you to find a bunch of different limits can be very fun. So just take your time with them, and they should come out nicely.